Times like these, times like those, what will be, so it goes, and it always goes on and on and on and... Hey, what's going on? What's up, my friends? I just saw a lot of you guys earlier on the Zoom chat. That was a lot of fun. You can see I still have my mustache here. I know. I tried to convert into Luigi, so I needed a mustache. Notice a Luigi hat. Back to a regular hat for our lesson, though. All right, y'all. So I am recording this on Thursday, April 23rd, which means you are watching it or should be watching it on Friday, April 24th. We are on lesson 9. The name of this lesson is PVC, easy as 0.1, 0.2, and 0.3. Again, lesson 9 means we've already done 8 lessons in this unit. You need to do those 8 lessons before it lets you go into lesson 9. Make sure you're caught up by the end of tomorrow. If you need help, reach out to me and I will do my best to help you. You can contact me on Google Classroom, or you can reach out and call me. That's totally fine. And I'll do my best to walk you through it over the phone. Hopefully this video is a big help too. Make sure you're doing for lesson 9, like all lessons, all 4 parts: number gym, blast. Then you're going to do Z-squad, that's your guided practice, and then you're going to end on independent practice, your tower of power. If you want to do your bonus question, go ahead and do that as well. When you're done all this, head on over to Edge Elastic afterwards to do your exit ticket at the end of the video. Again, I will provide some helpful hints and some tips and some tricks that will help you on that section of your assignment. All right, my friends, again, you're responsible for your fluency, your number gym, and your blast. I will pick it up with guided practice in our Z-squad part. Let's go ahead and click Z-squad.
Hi, my name is Stanley.
By the way, my friends, you're going to meet a whole new squad of friends today. They're going to help us out with a bunch of these. Make sure you're watching the videos. I think they're pretty cool. We're going to go over a bunch of different measurement units, and it's going to remind you of our measurement subject that we did before, our measurement unit that we did before. We're going to talk about volume and length and capacity and all that good stuff that we covered maybe about a month and a half, 2 months ago.
And I'm in the Zearn squad.
All right, spin the wheel to get a measurement problem. All right, let's see what we get. Spin the wheel with me. All right, it looks like we're going to start out with length. Let's compare the length of the blue and the green tapes to find which tape is longer. We can see we have meter sticks here. 1 meter, here's a meter down here, and it looks like they've taped it off and they've magnified it up here, which means they've zoomed in on it. We have our blue tape and our green tape. So just off the bat, without measuring, which is longer, our blue or our green? Blue or green? Think about that. You might want to write it on your scrap paper. Always have a notebook or a piece of scrap paper on the side to do your computations. All right, let's figure this out. Here's our meter stick up top. Let's look at our question. First, let's review the meter stick. How many centimeters are in 1 meter? Who remembers it off the top of their head? If you remember it, plug it in and then press enter, see if you're correct. If you need a little help, I think our measurements here might be a little nice guide. In 1 meter, we have 100 centimeters. Good work. Nice job, my friends. All right, now let's look at the first meter stick. What is the length of the blue tape? So if we look at this meter stick, it's going to start at 0 centimeters. And if we measure down, it's hard to see here. Notice the magnified image. Here we have 33 centimeters, 34, 35, 36, 37, 38, 39, 40. It looks like our blue tape goes all the way out to 41 centimeters. Let's plug that in. Not 41. There we go. Great job. Nice work.
I was looking at 2 meter sticks with two different tapes. One was blue and one was green, and the hole is 1 meter. I saw that the blue tape was 41 centimeters.
So did we. Nice job. How can we express 41 centimeters or 0.41? We can say it as 41 hundredths. Say it with me, friends. 41 hundredths meters as a fraction of a meter. So what does that look like as a fraction? Well, let's go to our place value chart. We have 0.41. We know that second decimal place is filled. 0.41. That means our hundredths place is filled. So when I write 0.41 as a fraction, I want to make sure I include hundredths. So this is out of 100. All right, that represents our hundredths place. And how many of them do we have? Well, you tell me. Fill it in. If you filled it in with 41, I think you did an excellent job. 41 hundredths. 41 hundredths here. Excellent work.
I recorded my blue and green tapes on a tape diagram. The blue tape had 41 hundredths. 41 hundredths is equal to 4/10 and 100.
All right, my friends, again, we don't have these note pages. That's fine. You can use your scrap work, your scrap paper, or your notebook. So let's shade tape diagram B to show the blue tape is 0.41 meters or 41 hundredths of a meter long. Then express 41 hundredths of a meter as a fraction. They did it for us here. We looked at it on the last page. Let's check our work. It looks perfect. Let's move on. All right, we're on to the green tape. Now let's look at the second meter stick. What is the length of the green tape? All right, let's get a closer look. So we started 0 again. This time we're going out, out, out. I can't see exactly what that is. Luckily, it's magnified up here. We have 30, 31, 32, 33, 34. It looks like it's 35 centimeters. Plug that in. 35 centimeters. Nice job. All right, what is 35 centimeters in meters? So if it's in meters, that means it's got to be out of 100 because there's 100 centimeters in 1 meter. 1 meter equals 100 centimeters. All right, so if it's out of 100, how many do we have? We have 35, don't we? 35 hundredths. Which of these three answers represents 35 hundredths? I want you to go ahead and select it, and then I'll show you my thought process afterwards. If you said 0.35, you were correct. We can read this as 35 hundredths because our trusty place value chart tells us 0.35 can be read as just 35, and then read that smallest place value, the place value furthest towards the right. 35 hundredths. 35 hundredths, 35 hundredths, represented three different ways: in our decimal format, as a fraction, and in our unit form. All right. So if we're going to do it as a fraction, we just did it on the back page, so I'll fill it in here. Write it on your notepad, on your notebook, or your scrap work. 35 hundredths. Nice job. And if we had to fill it in, here's 10, 20, 30, and I guess how many more should I fill in? How many hundredths? You guessed it, 5 more. 1, 2, 3, 4, 5. All right. That's about perfect. So I think we're starting to see that our green tape is much smaller than our blue tape up here. It's much shorter, I should say. We're measuring length.
The green tape is 35 hundredths. They're 3/10 and 5 hundredths.
All right, 35 hundredths as a fraction and as a decimal. They are equivalent. They are the same. Let's think about this. How can a place value chart help us compare the length? So luckily, you guys are ahead of the Zearn squad. start to think about how we can use our place value chart to start to compare these lengths.
Next, I recorded the lengths in the place value chart. I put blue by one line and green on the other line. By the blue, I put 0 because there's no meters, and then I put 4/10, and then I put 100.
All right, what we're going to do, we're going to slide over to our place value chart. We're going to erase what we have, and let's set it up. So here we'll do green on the bottom. We'll do blue on top, B for blue. Of course, I got to do it in blue. I'm sure some of y'all have blue as your favorite color. My favorite color is green. All right, so for blue, we have 0.41, no whole meters, 4/10, 1/100th, and for green, it was 35/100ths. Let's switch over to green. 0 whole meter, 0 ones, 3, and 5. Now, in order to compare our decimals, what we have to do is we have to go place by place and see which is a larger digit, which value is larger. So we want to know what's longer, B or G. If we look at our ones place, always start with your largest place that's filled. 0 and 0, they're the exact same, so that won't tell us anything. At this point, it looks like they're the exact same measurement. So we have to go to our 10th place, our next smallest place. Let's look at these. We have 4 and we have 3. Now they're different. One is larger than the other. What's larger? The 10th digit for blue or the 10th digit for green? If you're thinking blue, you're correct. This 4 is larger than this 3. So our blue, we don't even have, at this point, we know that this number, this 0.41 is larger than 0.35 because our 10th place tells us. We don't have to go to our hundredths. Our blue is, let's keep it consistent. Our blue is greater than our green. Notice my inequality there. It's open towards my blue because it's longer. And so we know that 0.41 41 hundredths of a meter is longer than 35 hundredths of a meter. All right, let's go back and check our work. They're going to plug it in one at a time. Now they're going to plug in 35 hundredths. Let's see what that looks like down on their place value chart. You can see it right here.
By green, I put 0 because there's still no meters. And then I put a 3 for 3/10, and then a 5 for 5/100ths.
All right, they've plugged it in, and now we can kind of see the comparison here compared to our place value chart that we just created. Tape blank is larger than tape blank. I think they want us to fill in a B or a G. We know that B is longer than G. So let's use our colors here, B. While I'm writing this, I want you to write this sentence, this answer statement on your scrap paper. Tape B is longer than tape G because 41 hundredths of a meter, or 0.41 meters, is longer than 35 hundredths of a meter, 0.35. Nice work, my friends. Good job. Let's write it in. Drag and drop, so click it and drag it up. We know B is longer than G, and 41 hundredths is longer than 35 hundredths of a meter. Nice work.
I only had to look at the tenths because I knew that that was the biggest unit. And then I saw that 4/10 is greater than 3/10. Then the green.
Let's pause for 1 second. He only had to look at our tenths. You do not have to move to a smaller place if a larger place tells you which value is larger. we can see here from our tenths, our blue has a 4, here's a 3, so our blue is automatically larger. Now, if they were the same, we'd have to go to our hundredths, and then that would hopefully tell us if there's a difference, which value is larger, our blue or our green. All right.
41 hundredths of a meter is longer than 35 hundredths of a meter.
All right, and here's our answer statement all filled in. Nice job. All right, what is another way to say 41 hundredths of a meter is longer than 35 hundredths of a meter? We could just convert it back to centimeters, right? We know we have 41 centimeters and 35 centimeters, and 41 is definitely longer than 35. Excellent job, my friends. Remember, you can always pause this video and go back if you need to rewatch it, if you want to rework a problem, if you want to practice your own place value charts like we practiced a couple lessons ago. That's why these YouTube videos are great, right? You can freeze them, you can move ahead, you can move back, you can stop, you can replay. They're really awesome. All right, okay, so we're done with length. Nice job. Let's see what we get next. Time for mass, let's do it. Now, what is mass? If you know what mass is, pause the video and write me a Google Classroom comment. I would love to know if you remember what mass means. If you have to look it up on Google, that's totally fine too. What does that measure? Pause the video now. All right, if you said that mass is sort of like weight, right? It's how heavy something is, then you were correct. So let's see what we're measuring the weight of, or how heavy something is. Let's compare the mass of this orange, this apple. It looks pretty tasty, this apple, although I'm partial to green apples. And the book to find which object is the lightest. So which of these is the lightest? What do you think? Take a guess. Write it down. Let's see if you're right. I think it's the book, but who knows? What do you think? All right, now that you have that written down, let's go to our first video.
Orange, an apple, and a book. I'm comparing how much they weigh. So first I compared the apple in the book, and it seems that the book is heavier than the apple. To show my comparisons, I used the greater than sign. The book is also heavier than the orange, but I can't tell which is lighter, the apple or the orange.
All right, my friends. So read the number on the scale. What is the mass of each object? So we're going to read these weights. Our apple is what? It looks like 25 hundredths of a kilogram. Here it looks like we have 3/10 of a kilogram. And this is 3/10 because notice we don't have our second decimal place. We only have our first decimal place. Our first decimal place is our tenths place. So 0.3, 3/10. And here 0.53, 53 hundredths. Nice job. All right, let's do the exact same thing. This time we're going to represent it in fraction form. So 25 hundredths, our second decimal place is filled. Notice hundredths, that means it's out of 100. And how many do we have? 25. Nice job. Here we have 3/10. I know it's 3/10 because I have no holes, no ones. And I have 3 in my tenths place and nothing in my hundredths place. So I can read this as 3/10. All right. This is out of 10. Out of 10, we have 3 of them. What is this out of? Tenths or hundredths? What do you think? What is our denominator? Tenths or hundredths? If you said hundredths, you're correct. It looks like our 3 is in our second decimal place. That's our hundredths place. We have 53 hundredths. Let's see if it's good. Great job. Nice work, my friends.
The book weighs 53 hundredths of a kilogram.
I wanted to pause this and show you for a second. I've been calling these inequalities. They're going to say greater than or less than symbol. This would be greater than because we always read our inequalities from left to right. The book is greater than the apple. The book is greater than the orange. Okay, so you might hear both. Make sure that you're using those terms and you feel very comfortable with them. Let's keep it moving.
The apple weighs 25 hundredths of a kilogram, and the orange weighs 3/10ths of a kilogram.
All right, on a separate piece of paper, your scrap paper or your notebook, record the mass of the apple, orange, and book in your place value chart. Go ahead and create this place value chart. You can hand write it. So what I want you to do, draw a line horizontally, draw 2 vertical lines, write an O for ones, make sure your decimal's right there. I'll do mine in a different color, just make sure yours is nice and bold. We'll put a T here for tenths. We'll put an H here for hundredths. All right. And then what I might do, I might put another line here. All right. And now we need to create 3 new rows. Here's one. Here's another. 1, 2, 3. We'll put our orange, our apple, and our book. Now, it's not as pretty as their chart, their table, but it'll work for us, right? We have a place value chart and we can measure our orange, our apple, and our book. So let's see. For our orange, we have 0 ones, we have 3/10ths, and there's no second decimal place filled in here. So I'm actually going to put a 0 here just to have each of these filled. 0.30 or 0.3. You can say it either way. All right, we did the orange. I want you to do the apple and the book. Pause the video now. When you're done, play the video and you'll see what we do to finish up this table. You can check your work against what I do. I'll see you in a second. All right, for the apple, they have a red apple, so we'll make sure we have red here. For the apple, 0 ones, 2/10ths, put our decimal point, and 5 hundredths, 25 hundredths, 0.25. And for our book, let's do yellow for the book. 0 ones, 5/10ths, and 3 hundredths. Make sure we have that decimal point. All right. So our chart's all filled in. Nice work, my friends. I hope yours looks like mine. If it doesn't, pause the video now and make sure you write this down. Get this chart on your scrap paper.
To record my weights, I used the place value chart. For the orange, I put nothing in the ones, 3 in the tenths, and nothing in the hundredths. And for the apple, I put nothing in the ones, 2 in the tenths, and 5 in the hundredths.
My friends, you'll notice for this first one, I put a 0 here. Remember, our zeros are free. If they're after or behind your last decimal place, you could put a 0 there. You don't have to, though, okay? It's not totally necessary because we only have tenths in our measurement for the orange.
And for the book, I put nothing in the ones, 5 in the tenths, and 3 in the hundredths.
All right. So it looks like our place value chart does match hers. So we are good to move on. All right. So use the symbols to complete the comparison sentence. What is our smallest fruit? This is less than. So this fruit is less than. Well, I gave you a hint for the first item. This item is less than our second item, which is less than our third item. So it looks like our smallest, or our lightest rather, was the apple. This weighs the least. Then our orange. And then our book. I think. What do you think? Before I press enter, I want you to fill it in on your own. And then press enter and see if you're correct. let's see what it looks like if I do this. Maybe it's right, maybe it's wrong. Oh, incorrect. Let's see why. So if we look, let's try again. Which object has the smallest value or the smallest number in the tens place? Ones are the same. So we have to move to our tenths to compare. Our orange has 3/10. Our apple has 2/10, and our book has 5/10. They're all different, which means one is larger, one is the next largest, and the third, and then there's another that's the smallest. Okay. So which is the smallest value? 5, 2, or 3? If you're thinking or you said 2, you're correct, which means our apple is the smallest. So our apple's the smallest. Even though this is 3, that's the same as saying 30 hundredths. If I put a 0 back there, it's 30 compared to 25. So let's see. Good work. Our next smallest would be our orange, and then our book would be our largest. Good work. Apple weighs less than our orange, which weighs less than our book. Excellent work. All right, make sure you have that filled in. I'll just do A for apple, weighs less than the orange, and the B for book. Let's check our work. We'll plug it in, drag and drop. Apple weighs less than the orange and the book.
The book was the heaviest. It weighed 53 hundredths of a kilogram. Even though the apple weighs 25 and the orange weighs 3, I know that the orange is heavier. Because I know that 3/10 is the same as 30 hundredths. And 30 hundredths.
This is key right here. 3/10 is the same as 30 hundredths. That 0 in the hundredths place tells us. Okay? So it's always smart to plug that in just so you can compare your decimals.
The apple weighs less than the orange and the book.
Notice that beautiful answer statement. I love that. Just to make it clear for your audience exactly what your solution is and what you've found. All right. I have a feeling we're going to do volume next. Start to think about what volume means. All right. What do you think volume means? You can look it up on Google, but if you already know it, I want you to go to Google Classroom now and in a private comment to me, let me know, what is volume? What does it measure? You can pause the video now. Oh, you're back. Okay, so volume, what does that mean? It means how much space something takes up. It's the capacity. It could also mean how much you can fit inside of something. All right, let's compare the volumes of the liquid in the graduated cylinders. These are graduated cylinders here. I'm sure you've seen them in Miss Costello's class. You use them a lot in science. So they all have different volumes, which means they're all filled to different levels. I can't quite see it. I think they're going to magnify it coming up here.
There were 4 cylinders and each had a different amount of water. All the volumes were less than a liter. The first cylinder had 19 hundredths of a liter.
What volume did Devonier record for cylinder A? Let's see. So it looks like, okay, I see what we're doing. So here's our whole graduated cylinder, and we have 1 liter. That's to the top, right? Almost to the top. So we have less than that. We actually have less than 0.20. And if we magnify it here, what is our actual measurement? Well, it starts at 0. And if I count my tick marks, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 10. All right. And these are actually milliliters here. So 10 milliliters, 11, 12, 13. If I count up, it's 1 less than 20. What is 1 less than 20? If I'm 20 years old, how old was I the year before? If you said 19, you were correct, but it's not 19 here. It's 0.19. 0.19. 1 milliliter less than 0.20. Nice job. All right, let's try this on your own. I'll read the question. Try it, press enter if you got it incorrect, and make sure you're checking my answer here. What are the volumes for the other 3 cylinders? Pause the video and try now. All right, if you said for this one, it's more than 30 milliliters. It looks like it's about halfway. So here we have 35 hundredths of a liter, 35 hundredths of a liter. Nice job. Here we have a little bit less than 30 hundredths. That'll be 29 hundredths, just a little bit less. And here we have a couple milliliters less than 20 milliliters. So that's a couple hundredths less than 20 hundredths. 17 hundredths will be our answer. Excellent job. Okay, we're going to do the same thing, but we're going to record our decimals as fractions now. Here we can see 19 hundredths is written as 19 hundredths here, 19 over 100. What do we put in the denominator for 35 hundredths? If you plugged in 100, nice work, you are correct. What goes here in our numerator? How many do we have? We have 35 out of 100. Good work. Here we have 29 hundredths. Pause the video and try the last one on your own. If you said 17 hundredths, I think that you were correct. Nice work. We got all 3. So as you can see, we're working a lot with equivalency. Our decimals up here have equivalent fractions underneath. Get a really good look at this, okay? You'll see something very similar on your exit ticket. All right, I want you to create your place value chart again. I'll start it for you. Draw a horizontal line. All right. Our hundredths will go here. Our tenths will go here. Our ones will go here. And I'm actually going to do another one and put our items on the side. Make sure you draw it large enough. We need a decimal point. I'll do it in baby blue. Matches the shirt a little bit. All right, let's draw some rows. This will be for A. This will be for B, C, and D. A, B, C, D. Y'all are better artists than me. I know your charts are going to look really crisp and really clean. If you want to take a picture and show me what you put down, you can take it and you can upload it right to Google Classroom. All right, let's go ahead and do this. So if you want to try and fill the chart in yourself, I think that'd be really cool. If you want to follow along with me, that's totally fine too. You're going to be writing in your notebook or on your scrap piece of paper right now. So for A, we have 0 ones, no whole liters, 1/10 and 9 hundredths. For B, we have 0, and I think we have 0 liters for all these. So I'm just going to put the 0 here. All right. We have 0 ones, 3/10, 5 hundredths. Okay. Here we have 2/10 and 9 hundredths for C, and for D we have 1/10 and 7 hundredths. Nice work.
I filled out a place value chart to help me compare the volume of the cylinders. I labeled the chart with A, B, C, and D.
Your chart should match the chart here on our slide. Make sure you pause the video and copy that now. Okay, let's use comparison symbols to order the cylinders from least volume to greatest. So we're going to start with our least, which is our lightest or our smallest. So in order to compare decimals, you are putting them in a place value chart and you are stacking them just like this so you can compare each place. Our ones are the same, so this won't help us. We have to go to our tenths. Our smallest So we have a 1 here and a 1 here. So those are the smallest, but they won't help us because they're the same. So for those two measurements, A and D, we have to look at the next smallest. What's smaller, 9 or 7 for our hundredths place? 9 or 7? We know 7's smaller, so that means D is our smallest volume. Let's write D first. All right, and I'll put its measurement under here. 0.17, 17 hundredths. And I'm done with that, so I'm going to cross it out. I've already listed it. That's the smallest. We'll do it 2 different ways. All right, next. Well, now I can go back to my tenths, and I can see the one up here for A is the new smallest, so that goes next. Let's do A and 0.19, 19 hundredths. And notice 19 is larger than 17, so this flow makes sense. All right, next, and I'm going to cross it out because we used it. Next, we have B and C. So we go back to our tenths. Our 3 is larger than 2. That means 2 is smaller. So let's put 0.29 or C next. 29 hundredths. And notice 29 hundredths is more than 19 hundredths, which is more than 17 hundredths. Okay? Think about it like when you have the same unit. So when they're all hundredths, you can just think about it like your whole numbers. 17 smaller than 19, which is smaller than 29. And that leaves one more. B is our largest. That's 35 hundredths or 0.35. All right, my friends, get that written down. I want you to write both of them just so you can practice using your inequality symbols. And then when you're done, you can hit next. Let's plug it in. I think we had, let's see, I think it was D, A, CB. I think it was CB, but I'm going to show you what it looks like if you get it wrong by accident. What it'll do, it'll spit you out to a new page, and it'll show you your place value chart. So if you get it wrong, that's okay. All right. These questions are actually really helpful because they test your knowledge. Try again. Which place value should you compare first? You should always start with your ones. Your largest place, always start with the largest place value. They're all the same though. So it's going to have us go to the next place. All the volumes have a 0 in the ones place. Which place value should you compare next? So if your ones are all the same, it's not going to help you. You got to go to your tenths next. Your next largest. Good job. All right. So it looks like our smallest, like we said, was A. We can see that that is smaller than D. Oh, I'm sorry. Let's try again. That was my mistake. I can see 17 is smaller than 19. So let's plug in D. There we go. Great job. Now A. And look, I'm going to cross it out. D, we used you first. A is the next smallest. After that, we can see that C, 29 hundredths, is the next smallest. Cross it out. Keep myself nice and organized. And then last but not least, B is our largest volume. Nice job.
All of them had 0, 1, so I needed to look at the tenths place. 3 tenths was the biggest number, so container B had the largest volume.
I want you guys to get used to writing your numbers so they're stacked. If I'm comparing 0.19 and 0.35, stack them so the places are vertically lined up. Okay, 0.19, 0.35. And from here, notice I can go place by place, my ones place. They're the same, so it doesn't help us. our tenths. The 3 is bigger than the 1, so 0.35 is larger than 0.19, or 35 hundredths is larger than 19 hundredths. Let's keep watching.
And I looked at the other three numbers and compared to see which one was the biggest out of those three. Now I know that container C had the second largest volume. There is only 2 containers left, container A and container D. They both have 1/10, so I had to go to the hundredths place. In the hundredths place, I saw that container A had 9 hundredths and container D had 7 hundredths. I knew that container A was bigger because 9 hundredths is greater than 7 hundredths.
All right, nice work. D is smaller than A, which is less than C, which is less than B.
The order from least to greatest is D, A, C, B.
I compared 3 different masses. Colin, what did you compare?
I compared 2 different lengths. In my problem, I had to compare 4 volumes.
All right, plug these in and then see if you are correct. We're going to match the correct unit to the pictures. You can see our meter sticks need meters. Here we measured mass or weight. We use kilograms for that. And last but not least, we use liters for volume. Nice job.
The tool that I used to compare was the place value chart. So did I.
We were still able to use the same tools to compare.
This is your best tool. My friends, pay very close attention. Your place value charts are key. Make sure you're drawing them. Make sure you're stacking your decimals so the places all line up. You know they're lined up if the decimals are all in line. Notice each of these. The decimals are all in line. They're all lined up. So I know my places are lined up. My ones with my ones, my tenths with my tenths, and my hundredths with my hundredths. All right? Let's go to the Tower of Power now. We did a really good job on that. All right, my friends, let's jump right into the Tower of Power. It's already been a longer lesson than usual, but I did want to go through all 3 of those because they combined a lot of the ideas that we've gone over in the past. We looked at fractions. We looked at our tenths and our hundredths place of our decimals. We looked at a bunch of different measurement units. We looked at mass. We looked at volume. We looked at length. It's a really cool lesson. So we'll jump right in here and hopefully we'll go quick. Again, try these on your own. Once you try them, if you're having trouble, then come to the video. I'm only going to give you the answers here, okay? I want you to watch the last part for my suggestions on how to solve them. Order the cylinders from least volume to greatest volume. All right. We have our 0.3 liters here, 0.4, and 0.28. I'm going to stack them. 0.3, 0.4, and 0.28. Okay, if you notice, I have ones. I have my ones place. I have my tenths place. I only have hundredths in one of my numbers, so I'm going to put a 0 here just so I can compare hundredths if I have to. All right, our least, which is the smallest? Well, now I can see 28 hundredths is our smallest. 28 hundredths is our smallest. Let's put that right up here and then cross it off. You are writing this on your own scrap paper. Stacking is one of the most important things you can do when you're solving these problems, when you're comparing decimals. Next, what's larger? What's smaller? We have 30 hundredths and 40 hundredths. I think the next smallest would be 30 hundredths. It's less than 40 hundredths. Let's cross it off because we're about to use it, and then we'll plug it in. Now here it's 3 tenths, but we know that's the same as 30 hundredths. And last but not least, our greatest is 4 tenths. Good work. All right. 28 liters has the So we'll come back up here. I think, oh, they want us to plug some things in. So 28 hundredths of a liter has the least volume because 28 hundredths has fewer tenths than 3/10 and 4/10. Good work. 4/10 of a liter has the greatest volume because 4/10 has more tenths than 28 hundredths and 3/10. So we're basically creating answer statements to describe our comparison model right here. Let's see if it's correct. Excellent work. Let's keep climbing. All right, my friends, first record the mass of each item on the place value charts. Here we have 3/10 of a kilogram. That's for our orange. Let's plug that in, 3/10. It's no ones I can see. I have 3 in my tenths place. I'm just going to leave it like that. For my ones here, for my banana, I have 0. For my tenths, I have 2. And for my hundredths, I have 3 hundredths. And so we're missing, it won't even let me go on. I guess it does want me to fill this in. What can I fill this in with? What do you think? If I know I don't have any hundredths, but I need to put a number, what hundredths would represent that nothing? That I almost said it. If you said 0, you're correct. Nice job. All right, which one's larger? I want you to stack it. Write this on a separate piece of paper. 0.30. Our oranges. Make sure everything's lined up. Put your 0 here. That's our ones. Decimal place. Let's put our 2 under this tenth, under our 3. And let's put our 3 here. And if you want, I did it on the side here because you're not going to have this on your, you're not going to have it so like nice and neat on your scrap paper. But no, I tried to line these up as well as I could. You could do it like this, 0.23, right? But we're going to use this picture for now. So I don't have any ones. This won't help me. Let's go to our tenths place. This will help me. Our 3 is larger than our 2. So we know 3/10 is larger than 23 hundredths. 3/10 is larger than 2/10. Use that stacking method. You'll get to the answer like that. The orange is heavier than the banana. We can see it's heavier than the banana. Good work. Let's keep climbing. All right, let's read our question up top. Jessie shaded tape diagrams to represent the lengths of 3 strings she measured. List the lengths of the strings in order from the shortest to the longest. So the shortest to the longest. All right. String. First express the length of string 1 in decimal form. So this is 1 meter. So we know 1 meter can be broken up into 100 centimeters. I'm going to write that down here. 1 meter equals 100 centimeters. So they start by breaking it up into tenths. So each of these is worth 10 centimeters. We have 10, 20, 30, 40, 50, 60, 70 centimeters. But then we have a few extra. So 70, 1, 2, 3, 4, 5, 6, 7. If you said 77, this is actually incorrect because it's not 77 meters. It's 77 hundredths or 77 centimeters. So we want to write this as 0.77. 77 hundredths of a meter because we have 77 out of 100 centimeters. We have 77 out of 100. Let's keep it going. String 2. All right, this one is, it looks like it's all tenths here. So let's count by 10. We have 10, 20, 30, 40. And I'm going to do it differently this time. This is 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 7/10 when I add them all up. Okay, how can I write that as a decimal? Let's look at our place value chart as a decimal. 7/10. There's no whole numbers, nothing in front. So 0 in my ones place, decimal to represent our fraction. I have 7/10. Let's look at our tenths place. I put a 7 there. All right. That's an ugly 7, but it works for us. All right, 0.7. Let's plug it in. 7/10, 0.7. Nice. And last but not least, let's leave out that 1. This time I'm just going to count it here. I have 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. So 6/10 and 1, 2, 3, 4, 5, 6. Now these are broken into hundredths, right? So I have 6 more hundredths. So I need a 6 in my tenths place, a 6 in my hundredths place. Let's see what that looks like here. 6 in my tenths place, 6/10, and 6 hundredths, 0.66. I can read it as 66 hundredths, 66 hundredths. Nice job. All right, let's compare the lengths. I want you to stack these up. 0.77. Let's do 0.66 and 0.70. Okay. Let's look at our ones place. They're all the same. That won't help us. Let's look at our tenths place, which is the smallest. We have a 7, a 6, and a 7. I can see 6 is the smallest, so we'll use that first. This is our smallest string. Our next smallest, well, 7 and 7 are the same now, so we have to go to our next smallest, our hundredths place. Okay, so we have a 7, and this is actually a 0 here. So what is smaller, 7 or 0? I think we all know that it's 0, so 70 hundredths will go next. And last but not least, 77 hundredths. This is our correct order. Nice job. All right, my friends, that's it. You Zearned it. Good work. We're going to do a lot. All your exit ticket's really just going to be comparing decimals, all right? Again, if it gives you a couple decimals and asks you to compare them, 0.61, 0.7, 0.32, you need to stack them up so that the place values are all lined up. 0.61, 0.7. And notice, this is only a tenth. So I'm going to put a 0 to make sure my hundredths place is filled. And 0.32. You're going to have to do the stacking on your own, okay? So make sure you have a piece of paper ready. I want you to try your best and go place by place and see which one is the smallest, which one is the largest. Make sure they're in the right order. For this one, let's just do it really quick before I leave for the video. We can't use our ones place. Let's look at our tenths place. It looks like our 3 is our smallest tenth, and then our 6, and then our 7. I'll do the 3 first. Notice I cross it out when I use it. Is less than, my less than symbol, 0.61, which is less than 0.70. All right, my friends, I want you to watch this video. Do your best. If you need help with your exit ticket, just reach out to me, and I will see you guys soon. All right, have a great one.